Good evening, everyone. Very good evening. So, welcome to Kreatryx channel. So, guys, am I audible to you? So, very good evening, all of you. Welcome to Unacademy. Welcome to Kreatryx channel. So, welcome to the session of Brahmastra batch network analysis. So, let's start today transient. So, आप लोग अभी तक क्लास जो अटेंड किया इसमें हमने तीन क्लासेस ले लिया. एक क्लास में हमने बेसिक्स कंप्लीट किया, एक क्लास में नेटवर्क थ्योरम्स और ट्रांजिएंट्स, और चार क्लास बाकी है. आज और परसों कल हम तो ट्रांजिएंट डिस्कस करेगा. परसों और नेक्स्ट डे पे वी विल बी डिस्कसिंग व्हाट वी कॉल AC analysis and theory and its corresponding problems. So this is the plan for the Brahmastra batch. I hope you people have already completed the last three classes. So today we are going to start the new topic, that is transient. Okay. So kindly confirm, guys. Am I audible to you? Everything is fine from my side. Just a moment. Let me check. Right. Okay. Then let's start. So before starting the session, let me give you some updates regarding the present batches going on with Unacademy Plus subscription. That is the Udan batch and Bunyad batch. In both the batches, network theory is started by Umesh sir on December 21st. So if you want to start your journey for GATE and PSU for 2024 and 2025, you can take the subscription with an academy and start your preparation journey. So when you take the subscription with an academy, you can use my code Shankar10, which will give you 10% discount or the maximum possible discount at that particular time for an academy subscription. When you or your junior anybody want to take the subscription, you can refer this code. So all these are the what we call USPs of this particular बैच. गाइस आपको जल्दी से शुरू हो रहा है ये वाला बैच, दिसंबर से शुरू हो रहा है. आपको 14 months टाइम ahead of your great examination it is going to start. It was started. So because of this आपको थोड़ा सा फायदा भी होता है. जैसा आपका सिलेबस कॉम्प्रिहेंसिवली कवर हो पाएगा, इसके बाद रिवीजन बैचेस भी हो जाएंगे, रिवीजन हो सकते हैं, and you will be getting more number of practice questions. 5000 plus questions मिलेगा including the gate PYQs. आपको रेगुलर डाउट सॉल्विंग क्लासेस हो जाएगा, डाउट डेली प्रैक्टिस थ्रू क्लास डीपीपी मिलेगा. ये सभी आपको बेनिफिट्स है दिस पर्टिकुलर बैच में. ठीक है. So you can see all the leading educators are available in this particular batch for electrical and also EC students. Okay. So this is our batch for mission IRMS. Those who are aiming for IRMS examination, they need to clear the prelims of the civils examination. I mean, they need to prepare the content of the civils UPSC prelims and the gate together. For them, an academy brings the new subscription, guys. That is Mission IRMS 2023. So this batch also started recently. If you want to start your journey, you can take the Unacademy subscription with UPSC and GATE together. So let's start the journey of the transients. So in our regular classes, we discuss little more about the transient. Already theory पे बहुत time we spent, but here it is a, I hope you know what we call the crash course. So इसलिए इसमें ज़्यादा time तो हम waste नहीं करते. थोड़ा सा little fast theory quickly I'll finish it and I will move for what we call the problems. So transients. आज थोड़ा सा ज़्यादा theory discuss करते हैं because this transient. So your plan is like this. Next schedule तो ऐसा है. आज का डेट कितना है यार? 27 था. 27 and 28. Daily timings will be 4 p.m. to 5:30 p.m. Time can be आगे पीछे हो सकते, maybe up to 6 p.m. we can go. Depends on the time we start or the content we are going through. So we discuss the transient. That is today and tomorrow we will be discussing transients only. 29 and 30 we will continue with the AC analysis. 30 के बाद अगर चाहिए तो maybe after 2 sessions of AC analysis, if required, I'll take more time and I'll take few more sessions. Not an issue for me. ठीक है. So mostly this will be done by 30th. 30th तक syllabus तो हो जाएगा मेरे हिसाब से. So that is the next 4 days. This is the plan. ठीक है. So today we are going to start the transient. So let's start. So there is an electric network. All of a sudden, you are giving energy to the network. All of a sudden, you are giving energy to the network, or you are removing the energy from the network. Maybe how you give energy, source is connected, or source is removed from the network. If the network contains the elements like inductor and capacitor, they can't accept the sudden change. All of a sudden, आप ज़्यादा energy दे रहा है, ओके कोई भी एनर्जी दे रहा है, इसके एग्जिस्टिंग एनर्जी से ज्यादा और कम दे रहा है, ठीक है. दैट इज ऑल ऑफ a sudden you want to give some energy or you want to remove the energy from the network. The presence of these inductors and capacitors, what they will do is they will oppose this sudden changes. Because of this opposition, what happens is there will be some sort of disturbance. जैसा सपोज यू वांट टू, ये तो ह्यूमन नेचर होता है ना. जैसा आप लोग 4 बजे तक, 4 बजे आपको क्लास है, 4 बज के पहले आप कुछ काम पे है, सडनली 4 बजे में तो मैंने बताया आपका क्लास शुरू हो जाएगा, थोड़ा सा टाइम लगेगा आपको एडजस्ट होने के लिए. ओके. सो इसलिए हम लोग गुड मॉर्निंग बोल के, कुछ इंट्रोडक्शन बोल के, हम कल क्या डिस्कस किया, ये सभी चीज डिस्कस करके आपको आई विल ब्रिंगिंग यू इनटू द मूड ऑफ द क्लास. वो पार्ट जो होता है ना, इसको बोलते हैं ट्रांजिएंटरी पार्ट. सो हम भी एक स्टेट से दूसरा स्टेट, अभी तक आप कुछ काम कर रहे हैं, अभी तो आप क्लास पे है, सो एक स्टेट से दूसरा स्टेट में चेंज करने के लिए हमको भी थोड़ा सा टाइम लगेगा. द सेम वे द मेमोरी एलिमेंट्स प्रेजेंट इन द नेटवर्क, इंडक्टर, कैपेसिटर, वो इन लोगों को भी थोड़ा सा टाइम लगेगा टू चेंज इट्स स्टेट. जिसको बोलते हैं ट्रांजिएंटरी स्टेट. सो यू जस्ट इमेजिन द मोमेंट अलार्म रिंग्स, you are sleeping, morning 6 a.m. you kept the alarm. So alarm rings and at 6 a.m. you will be behaving little weird, or you might be having some sort of what we call vibrations, like that you will be having in your mind. आप लोग सोचते हैं, shall we continue the sleep or shall we get up and start the class. ऐसा सोचते ना every time you wake up. ये वाला थोड़ा सा फेज जो होता है ना, वो फेज जो होता है उसमें आपका काम अलग से होता है. जैसा आप रेगुलरली when you are sleeping happily you are in the stable state, when you wake up perfectly and doing your work you are in the stable state. बीच में जो टाइम होता है ना, आप उस समय पे थोड़ा सा अलग से बिहेवियर करते हैं, आपका बिहेवियर अलग से होता है उस समय पे. वो आपका बिहेवियर जो होता है ना, वो बोलते हैं ट्रांजिएंटरी बिहेवियर. द सेम वे whatever your behavior, electric network behaves before reaching one state to another state, the transition time पे जो काम होता है ना, इसको बोलते हैं transitory period. We should know or we should analyze this transitory behavior of the system, because we should understand कितना टाइम लगेगा सिस्टम स्टेडी स्टेट पे आने के लिए. आप जो इनपुट दिया, इसका आउटपुट मिलने के लिए कितना टाइम लगेगा, that matters a lot. Similarly, during the transitory period, ये सिस्टम कैसा काम कर रहा है. Is it giving you some peaks which can disturb my system? Is my system is safe during this transitory period? All this analysis is possible provided you know the transient behavior of the system. इसलिए हम compulsory we should read the transitory behavior of the system. Say for example, say this is the time scale. This is the time t equal to 0, 0 plus, 0 minus, and infinite. ये तो माइनस इंफिनिटी, ठीक है भाई. ये जीरो का मतलब क्या सर? जीरो इज द पॉइंट वेयर आई एम ऑपरेटिंग द स्विच, आई एम डिस्टर्बिंग द सिस्टम. Your alarm rings now, that is the point of zero, we can say. Okay, when the system is happily in one kind of particular steady state, then suddenly we disturb the system at the time t equal to zero. It may be giving the source or removing the source, whatever it may be. Zero is the point where you operate the switch. Zero के पहले, just immediately before the zero, zero minus. जीरो माइनस का मतलब माइनस पॉइंट नॉट 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 वन. इट इज ऑलमोस्ट इक्वल टू जीरो, जस्ट बिफोर जीरो, इसको बोलते हैं जीरो माइनस. दैट इज आप लोग नींद पे है भाई, यही पे अलार्म रिंग हो गया. ये अलार्म रिंग होने के थोड़ी सी पहले जो है ना, आप बहुत अच्छी सी स्टेडी स्टेट पे है, यू आर स्लीपिंग हैप्पीली, दिस इज जीरो माइनस. नाउ जीरो पे अलार्म तो रिंग हो गया, सिस्टम तो डिस्टर्ब हो गया, एंड जीरो प्लस प्लस पॉइंट नॉट इमीडिएटली आफ्टर द स्विचिंग एक्शन. इस समय पे क्या होता है सर? दिस इज इमीडिएटली आफ्टर द स्विचिंग एक्शन वेयर यू आर इन द ट्रांजिएंट स्टेट. सो ये दोनों के बीच में जो डिफरेंस है ना, वेरी लेस. जीरो प्लस और जीरो माइनस के बीच में 0.00002, विच इज ऑलमोस्ट इक्वल टू जीरो. तो बहुत 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 कम है. वी कॉल दिस एज इंस्टैंटेनियसली और within zero टाइम. से हमारा बॉडी ऐसा है, विद इन जीरो टाइम पे एडजस्ट नहीं हो पाएगा. अच्छी सी नींद पे है, सडनली आपका अलार्म रिंग हो गया, सो सडनली विद इन जीरो टाइम यू डोंट चेंज योर स्टेट एंड यू विल बी गोइंग फॉर द स्टडी इमीडिएटली. ठीक है. द सेम वे सिस्टम आल्सो इंस्टेंटेनियसली कैनॉट चेंज, मेनली द इंडक्टर्स एंड कैपेसिटर्स. सपोज इफ यू टेक द इंडक्टर का एनर्जी जो होता है ना, फॉर्मूला हाफ एल आई स्क्वायर. कैपेसिटर का एनर्जी जो होता है ना, हाफ सी वी स्क्वायर. You see, the IL and VC equation mathematically depends on integration. What is the equation for inductor current formula? 1 by L integral V dt. What is the equation for VC? 1 by C integral I dt. ये दोनों equations जो है ना, ये are depending on integration. So, they cannot change mathematically also. Its own nature or mathematically they cannot change instantaneously. When they cannot change instantaneously, आपका energy जो होता है ना, वो भी instantaneously change नहीं हो पाएगा. सो आप सडनली चेंज करना चाहिए, जैसा यहीं पे सोर्स नहीं है, यहीं पे सोर्स दिया, नहीं तो यहीं पे सोर्स है, यहीं पे सोर्स निकाल दिया, यहीं पे एक सॉर्ट ऑफ सोर्स है, यहीं पे दूसरा सॉर्ट ऑफ सोर्स है. ऐसा सडन डिस्टर्ब किया तो इंस्टेंटेनियसली इनका एनर्जी तो चेंज नहीं हो पाएगा. इसलिए क्या होता है ना, दे विल अपोज दिस सडन चेंजेस. बिकॉज ऑफ दिस अपोजिशन आपको नेटवर्क पे कुछ डिस्टर्बेंस हो जाएंगे. इसको बोलते हैं ट्रांजिएंटरी बिहेवियर ऑफ द सिस्टम. सो this behavior happens with inductor capacitor but not for the resistor. क्योंकि resistor ऐसा है, इसका voltage V equal to current I into R. इसमें there is no dependence on time. Ideally, it can take any amount of current instantaneously when you apply some voltage, and vice versa. Maybe it has some rating limitations and all practically, but this is what we are discussing ideally. So a transient जो होता है ना, वो RL नेटवर्क, RC नेटवर्क, RLC नेटवर्क, LC नेटवर्क में होता है भाई, बट प्योर रेसिस्टिव नेटवर्क पे नहीं होता है. ठीक है. So let's read those points. So the transient in the electric network is due to the presence of energy storing elements both inductor and capacitor. Transients कौन होता है भाई? इंडक्टर और कैपेसिटर के कारण से होता है भाई. ठीक है. एनर्जी प्रेजेंट इन द मेमोरी एलिमेंट्स क्या बोलते हैं? इंडक्टर कैपेसिटर कैनॉट चेंज इंस्टेंटेनियसली. इंस्टेंटेनियस का मतलब आपको पता है, विद इन जीरो टाइम. क्यों? ड्यू टू इंटीग्रल डिपेंडेंस ऑफ द मेमोरी वेरिएबल्स एल एंड सी. If the network contains only resistor, केवल और केवल नेटवर्क पे रेजिस्टर ही है, तो ये ट्रांजिएंट्स तो नहीं हो पाएगा, बिकॉज रेजिस्टर कैन अकोमोडेट एनी अमाउंट ऑफ वोल्टेज एंड करंट. ये डीसी एसी का डिफरेंस जो है ना, वो तो छोड़ दो, वो बाद में हम डिस्कस कर सकते हैं. ठीक है. सो एक सिंपल एग्जांपल दे रहा हूँ प्रैक्टिकली. देखो, दिस इज ए फायर फाइटिंग सिस्टम. ठीक है. ये फायर डिटेक्टर है भाई, ये चारों फायर डिटेक्टर्स हैं. कोई भी जगह पे फायर हुआ तो, इस पर्टिकुलर जगह पे फायर हुआ तो it will detect and give it to the control panel. Then the sensor का input जो होता है ना, वो control panel के जाके it will immediately release the valves and the immediately it will sprinkle the water. ये system is design किया, ठीक है. So ये वाला system जो design किया ना, इसमें the moment the fire detects, internally relay कुछ होता है that should release the contact and it should open these valves, ठीक है. So relay के अंदर में भी you have a RL circuit. Then what happens is that the moment you detect the fire, how much time you are taking to release this fire, the between जो time होता है ना वो तो transitory period है. That matters a lot because it is a real time system and also it is in what we call emergency system. So इस वाला केस में कंपलसरी वी शुड emergency system है ना. इस वाला समय पे क्या होता है सर, it is compulsory, it should react faster. So it is quite important to know how the system behave in the transient tree. You can see this example. Okay, so let's move further. चलो, हेलो, गुड इवनिंग, ठीक है एवरीबॉडी. स्टार्ट तो किया भाई, once again. चलो, let's move. So, before going further in the transient, it is very important to know about the inductors and capacitors properly. Then only you can understand the transient behavior of the system. So, let's discuss about the basics of the inductor and capacitor. Here, I'll go a little quick because आपका हमारा time तो important है, तो crash course है ना, ठीक है. So inductor and capacitor at time t equal to 0 plus and infinity, ये कैसा behave करेगा at time t equal to 0 plus. For example, L at t equal to 0 plus. If you assume omega equal to 1 by t, 1 by 0 is infinity. Suppose you take time t equal to 0 plus. Inductor. Formula for inductor ZL is SL J omega L. Okay, omega is 0, so G t equal to 1 minute, 1 by 0, infinity. Omega is infinity, it is infinity, it will act like an open circuit. Capacitor, 1 by SC, 1 by J omega C, 1 by J infinity, infinite is 0, short circuit. So immediately after the switching action, inductor short circuit, so inductor to open circuit, capacitor to short circuit जैसा काम करेगा. Similarly, t equal to infinity, आपका omega equal to 1 by infinity, that is 0, right? So it is a DC, you can say. Inductor ZL equal to J omega L will be 0, short circuit. Capacitor ZC 1 by J omega C, 1 by J0, 1 by 0 is infinity, open circuit. So you can see here, so these two cases we call steady state, right? At steady state, for a DC excitation, inductor acts as a short circuit and capacitor acts as a open circuit. Okay, for a DC input at steady state, inductor short circuit, capacitor open circuit. सर ये गलत है ना, बिकॉज ओमेगा इक्वल टू 1 by t आपने ले लिया, वो तो गलत है ना, मेरे को भी पता है ये गलत है. Omega equal to not 1 by t, it is 2 pi by 10, t is the time period, right? So why I have taken this is for making, this is a like a simple shortcut. ZL equal to j omega L is not at all applicable for DC. It is applicable for AC and AC input only, sinusoidal input. But why I have applied is to make the to remember easily. You can use this. But we can say mathematical convenience के लिए t equal to 0 plus में 0 पे switch is operated from 0 to 1 or 1 to 0. ये cyclic change तो हो रहा है at a very less amount of time. So the frequency of this operation is assumed to be infinite at the initial state. And at a long time of the switching action, because the input is DC, frequency is zero, this assumption is correct and this can be right. But this is just for remembering easily. में तो ये वाला concept हम apply कर सकते हैं, but it is not truly, strictly speaking, it is not a valid explanation. So इसलिए हम क्या करना चाहिए? I mean, I can prove this more better way in the mathematically. हम आगे discuss करने में समय पे मैं prove करता हूँ, ठीक है? चलो, let's move further. So the meaning of the steady state, please. Steady state का मतलब क्या है सर? An independent source is connected or an independent source जो होता है ना नेटवर्क पे हमने कनेक्ट किया, नहीं है तो डिस्कनेक्ट किया, and don't disturb the network for a long time. Long time का मतलब क्या होता है सर? So what we call ideally हम infinite time तक disturb नहीं करना चाहिए, but practically we can say it is up to 5 time constant. थोड़ा सा ऑडियो कम कर रहा हूँ मैंने, ज्यादा आ रहा है ना. Now it is fine, I think. Yes, Aryan, perfect. ठीक है. When you don't remember the things, ये वाला हमेशा मदद करेगा. चलो. So long time ideally of infinite time तक wait करना चाहिए, practically up to 5 time constant, then it is called as a steady state condition. At steady state what happens? The energy present in the network will reach its final value. Final value का मतलब अगर चार्जिंग हो रहा है तो मैक्सिमम, डिस्चार्जिंग हो रहा है तो जीरो पे जाएगा. ठीक है. It may be maximum or minimum and it remains constant. Say for example, you take inductor at steady state. What is the energy formula in the steady state inductor? Half L I square. This will reach constant. So already half and L are constant. Na? So IL is constant, compulsory. Then what is dIL by dt? D by dt of constant will be 0 at steady state. At steady state dIL by dt 0 है तो LDI by dt 0. LDI by dt is nothing but voltage across the inductor. Next. What about the capacitor, sir? E equal to half C V square. A भी constant है, sir. Then VC equal to constant. Then dVC by dt, d by dt of constant 0. C dVC by dt 0. Current in the capacitor 0. ठीक है. Now listen carefully. Voltage 0 है तो कोई भी एलिमेंट को हम रिप्लेस कर सकते हैं शॉर्ट सर्क्यूट. करंट 0 है तो कोई भी एलिमेंट को हम रिप्लेस कर सकते हैं ओपन सर्क्यूट. इसलिए फॉर डीसी एक्साइटेशन, ठीक है, हम जो डिस्कस कर रहे हैं ना डीसी के लिए, ये सी तो अलग बात है. ठीक है. सो कांस्टेंट फॉर डीसी ओनली. एसी पे इट विल बी कंटिन्यूअसली चेंजिंग. ठीक है. So what I am saying is for DC excitation, inductor acts as short, capacitor acts as open. We can prove it mathematically in this way. Sure. Just a moment. Next, inductor current and capacitor voltage at time t equal to 0 minus and 0 plus. ठीक है. What is the formula for IL? इसको हम स्प्लिट कर सकते हैं ना, माइनस इनफाइनाइट टू 0 माइनस. ठीक है. Now this is IL of t. So inductor current and capacitor voltage at time t equal to 0 minus and 0 plus. This is IL. 1 by L integral minus infinite to t VL of t dt. VL of t dt. Okay. Now substitute time t equal to 0 minus 0 plus in this equation. Then IL of t will become 1 by L minus infinite to 0 minus a VL of t dt plus 1 by L 0 minus to t का जगह पे हम अब सब्स्टिट्यूट करना चाहिए 0 प्लस. ठीक है. So what is the current equation from minus infinite to t IL of t? So what is the equation from minus infinite to 0 minus? I can write this part as IL of 0 plus 0 minus plus because up to 0 minus plus. I already told you the difference between 0 minus and 0 plus. 0 minus 0 plus के बीच में जो difference होता है ना वो तो almost 0 point not 2 are very low, almost equal to 0. So the area incurred by this integration will be almost equal to 0 for कोई भी existing any practically existing input. ठीक है. So current 0 है तो इसका मतलब ही होता है open circuit. That's why 0 plus में because it is not allowing any extra current, we can replace inductor with a open circuit parallel with some initial current. So what is the final conclusion here? IL of 0 plus equal to IL of 0 minus. ठीक है. Similarly, I can say because energy का formula क्या equal to half Li square. Current cannot change means energy also cannot change instantaneously. ठीक है. EL of 0 plus is equal to EL of 0 minus. So that is about your first part, that is inductor current cannot change instantaneously for all practically existing inputs. Similarly, its energy also. This is the first part. Next, the same way we can also prove capacitor also. For example, see here. अरे भाई इंडक्टर का व्हाट वी कॉल एनर्जी कैनॉट चेंज इंस्टेंटेनियसली एक्सेप्ट तो किया हम लोग, बट इज इट इंडक्टर करंट? ठीक है, देयर आर एक्सेप्शंस ऑलवेज. यू आर सेइंग दैट आई कैन नॉट वेक अप इमीडिएटली, यार मेरे को टाइम लगेगा, बट देयर आर सम एक्सेप्शंस. आई कैन वेक यू अप इमीडिएटली व्हेन यू हैव सम एग्जाम. व्हेन फादर कम्स वी मे वेक अप इमीडिएटली कंपेयर टू व्हेन मदर कम्स एंड वेक यू अप. जैसा हर आदमी को डिफरेंट डिफरेंट ट्रीटमेंट होता है ना, ऐसा भी. ठीक है. You see this example. Okay. For example, when you are sleeping, I bring some water and throw it on your face. Immediately you wake up and sleep. That happens. Okay, immediately, instantaneously you can wake up. The same way, okay. For inductor and capacitor, if you want to give that kind of impulse is nothing but for this sudden change. It is possible to give you sudden change. Sudden change is possible for inductor also if you give impulse as the input. Okay. If the voltage across the inductor is del of t. Del of t का मतलब क्या सर? Impulse. I hope you know the basics of the impulse. I am not going to repeat the basics of the impulse. Impulse will exist only at time t equal to 0. 0 के पहले impulse तो नहीं है. At time t equal to 0, it is infinity. That is, the area under the impulse will be equal to unity. If you integrate up to 0 or after, 0 is included in the integration. So in this case, what is IL of t? 1 by L integral minus infinite to 0 minus VL of t is nothing but del of t dt plus 1 by L 0 minus to t del of t. So at time t equal to 0 plus, what is your IL of 0 plus? 1 by L minus infinite to 0 minus del of t dt plus 1 by L 0 minus to 0 plus del of t dt. अरे भाई ये वाला पार्ट जो है ना, इम्पल्स एग्जिस्ट एट 0 ओनली. 0 के पहले इम्पल्स तो नहीं है भाई, 0. सो 0 पे इम्पल्स है ना, एरिया अंडर द इम्पल्स इक्वल टू 1. सो 1 by L इक्वल टू 1. इसलिए प्रैक्टिकली एग्जिस्टिंग बोला प्रीवियसली, बिकॉज इम्पल्स जो है ना वो तो प्रैक्टिकली एग्जिस्टिंग नहीं है. इनफाइनाइट वोल्टेज तो हम जनरेट नहीं कर सकते, बट इट इज अवेलेबल थियोरेटिकली. ठीक है. सो दिस विल गिव यू IL of 0. This is IL of 0 minus. Okay. 1 by here IL of 0 minus equal to 0. IL of 0 plus equal to 1 by L. So yes, inductor current can also change instantaneously if you apply impulse as the voltage. The same way, energy in the inductor EL of 0 minus equal to 0. What about EL of 0 plus, sir? Half L I square 1 by 2 L joules. So this is about your inductor. The same way, for capacitor, I'm not going through the proof again now. Similarly, I can do for capacitor. Voltage Vc of t equal to 1 by C integral I of t dt. This is the equation. Okay. By using this equation, Vc of 0 plus equal to Vc of 0 minus. It cannot change instantaneously. Energy cannot change instantaneously. Okay. If Ic of t equal to del of t, Vc of 0 minus will be 0, but Vc of 0 plus will be 1 by Vc of 0 minus 0, 1 by 2 C. बस हो गया काम. So that is about your क्या बोलते हैं कैपेसिटर एंड इंडक्टर. सो इंडक्टर में सो फाइनल कंक्लूजन क्या, एक वर्ड चाहिए तो इंडक्टर करंट कैन नॉट चेंज इंस्टेंटेनियसली फॉर कोई भी प्रैक्टिकली एग्जिस्टिंग इनपुट. It can change for impulse voltage as excitation. Similarly, its energy. The same way we can say capacitor voltage cannot change instantaneously for all practically existing input. It can change for impulse as current as excitation. Similarly, its energy. So अगर आपका नेटवर्क में सर ये impulse कब होता है सर मुझको पता नहीं. How do I know when that impulse can happen, sir? Impulse occur कब होता है सर? Impulse occurs. Okay, identification of impulse voltage across the inductor and current in the capacitor. इसके लिए listen. When this impulse occurs means when there is a violation of KVL, impulse current, violation of KCL, impulse voltage occurs in the network. कोई भी नेटवर्क प्रॉब्लम सॉल्व करने समय पे आपको इंपल्स वाला कंडीशन आएंगे तो हमेशा सॉल्व द प्रॉब्लम बाय यूजिंग लैपलेस ट्रांसफॉर्म अप्रोच व्हिच इज द बेस्ट एंड इजीएस्ट पॉसिबल वे. ओके, let me show you that with the help of example. ठीक है, चलो here at time t equal to 0 plus what happens here, मैंने स्विच को क्लोज किया 0 पे. 0 प्लस में what is the equivalent? My switch is closed. Immediately after the switching action, my capacitor will act as what? अभी तो हम डिस्कस भी किया, टाइम t equal to 0 plus capacitor acts as a short circuit. Here वोल्टेज सोर्स का अक्रॉस शॉर्ट है, इसको बोलते हैं वायलेशन ऑफ केवीएल. केवीएल सेटिस्फाई नहीं हो पाएगा ना, सो इसमें v by 0 infinite current will flow. Practically ideally we can say impulse current will exist, but practically what happens is it ideal source will not exist. Practical source में internal resistance will be present and very huge amount of current will definitely flow. ठीक है. Similarly, these are the cases where you get spark in the system. ठीक है. Suppose you have a current source I. So switch is moved from position 1 to position 2 at time t equal to 0. So immediately after the moving the position, how can we draw the network? R1 को neglect करो, R2 and inductor acts as a open circuit. Current entering is I, leaving is 0. These are the examples of violation of KCL. Impulse voltage will occur. Because I into infinite will give you infinite voltage. Okay. Chalo, that is about your KCL, I mean basic equivalent circuits. Very important part अभी तो discuss कर रहा है equivalent circuits. और थोड़ा सा टाइम लगेगा थ्योरी डिस्कस करने के लिए, ठीक है, बिकॉज इट शुड बी कंप्लीट, ऐसा नहीं होना चाहिए थोड़ा सा थ्योरी दे के डायरेक्टली प्रॉब्लम में जाने, थोड़ा सा टाइम मे बी 15-20 मिनट्स टाइम लगेगा, देन वी विल मूव फॉर द प्रॉब्लम्स. लेट्स मूव. चलो, equivalent circuits. First I'll draw for inductor. Okay, let me draw, I'll explain, not an issue. This is the important figure regarding your inductor, regarding whole transient. कोई भी transient problem solve करने समय पे वो in one or some other way we always keep on using this figures. ये वाला चार figure जो है ना आप याद पे रखना चाहिए, आपको पता है तो भी ठीक है, मैं प्रूव नहीं कर रहा हूँ क्योंकि ये तो क्रैश कोर्स है ना, प्रूव भी किया तो ज्यादा टाइम लगेगा. सो आप लोग देख सकते हैं आपके पास इंडक्टर विथ इनिशियल करंट आई नॉट, द करंट इज आई एल ऑफ टी. At this node, if you apply KCL, you can prove both are, I mean, this figure is equal to this figure, fine. Okay, how we can replace inductor is, inductor with initial current I naught can be replaced with a current source of I naught parallel with a inductance. So this को Laplace apply किया तो SL होता है ये I naught for t greater than equal to 0 is I naught by S. इसको source transformation apply किया तो आपको ये मिलेगा, arrow direction negative to positive, SL series का आएगा, ठीक है. Here अलग अलग specific cases. So ये वाला circuit, let me draw at t equal to 0 plus and t equal to infinity. T equal to 0 plus में ये वाला circuit में I told that at time t equal to 0 plus inductor acts as a open circuit. So इसको हटा दो भाई. Okay. So IL of 0 plus is equal to, इसमें no current, open circuit. You know IL of 0 plus formula na, IL of 0 plus equal to IL of 0 minus plus 0. This is IL of 0 minus indirectly. Okay, we replace inductor with a open circuit at time t equal to 0. This equation is satisfied or not? Capacitor is voltage 0 at time t equal to 0 plus. Vc of 0 plus equal to Vc of 0 minus बोला ना मैंने. If you add Vc of 0 plus equal to Vc of 0 minus plus 0 आएगा. Voltage 0 means short circuit. That is the reason we replace capacitor with a short at 0 plus. Now see here. इसमें specific case, if I not equal to 0, अगर I नॉट 0 है तो उस केस में क्या होता है सर? हमको बार बार ये दोनों फिगर्स तो कंपलसरी यूज करना चाहिए. ठीक है. सो दिस इज these are the two cases. Next. ठीक है. Now the last case, steady state, time t equal to infinity, inductor acts as a short circuit. It can be input can be anything, it doesn't matter. That is, initial value can be 0 or non-zero, doesn't matter. See here, three possibilities. This is the equivalent circuit. इसमें मैं substitute कर रहा हूँ. T equal to 0 plus inductor is open circuited. I naught may be present or may not be present. But I naught high or नहीं high कोई दिक्कत नहीं. Time t equal to infinity. Provided network में और कोई element होना चाहिए compulsory. Okay, which can take this energy. This energy will be given to that element and inductor acts as a ideally short circuit. Whether initial value is present or not, all problems में हम t equal to infinity में inductor को replace करेगा short. But 0 plus में initial current है तो we will keep it, otherwise we don't keep. So final value are independent of initial value. Final values are independent of initial values. ठीक है. चलो next. The same analysis I should do for capacitor also. ठीक है. For capacitor, capacitor with initial voltage V naught for time t greater than equal to 0. Capacitor with initial voltage V naught. Okay, what is the equivalent? This can be replaced with V naught in series with the capacitance C. If you apply Laplace, ठीक है. If you apply the Laplace, this is the equivalent. Now the arrow direction negative to positive, CV naught. So these are the equivalents of the capacitors. Now here also इस वाला सर्क्यूट में कैपेसिटर का इक्विवेलेंट क्या है? इनिशियल वोल्टेज सीरीज विद द कैपेसिटेंस, टाइम t इक्वल टू 0 प्लस. ओके, t equal to 0 plus, capacitor acts as a, okay, initial voltage in series with a short circuit. अगर इनिशियल वोल्टेज 0 है तो सिंपली शॉर्ट सर्किट. ओके, if v not equal to 0, time t equal to infinity, whether initial value is present or not, blindly replace it with a open circuit. These are the necessary basics for understanding the transients. Okay, so we will be starting the problems. Just give me a few minutes of time. So quick revision of the what we discussed till now. You can see ideally it takes at least 2 hours to explain all these things. हम तो half an hour पे discuss किया ना basics of the transient. Whenever inductor capacitor contains the energy storing elements, this kind of transient can occur in your network. And this is the importance why we should study transient. So inductor acts as a short circuit, capacitor acts as an open circuit at steady state. Equal inductor current, capacitor voltage cannot change instantaneously. They can change for impulse as excitation. When there is a violation of KCL, KVL, you can get impulse in the network. And these are the equivalent circuits for inductor and capacitor. ठीक है, that is inductor को current source parallel with inductance, capacitor को voltage source series with capacitance. We will do the problems. Just give me 2 minutes, hardly 5 minutes of time. So because I need to give you necessary formulas. ठीक है, so there are 3 models of the questions come in your examination. Model 1, source free circuits. In the source free circuits, we have possibility of RL, RC, RLC. इन RL, RC, RLC सोर्स फ्री का मतलब पहले समझ होना चाहिए. नेटवर्क पे सोर्स होना चाहिए अप टू स्विचिंग एक्शन. हम जो स्विच ऑपरेट करते हैं ना, स्विच क्लोज और ओपन, इसके बाद नेटवर्क में after operating the switch, if the network doesn't, I mean network is not having any independent source after the switching action, इस वाला नेटवर्क को बोलते हैं स्विच सोर्स फ्री नेटवर्क. ठीक है सर. देन हाउ द नेटवर्क वर्क्स आफ्टर रिमूविंग द सोर्स. सर अभी तक सोर्स हुआ, सडनली मैंने सोर्स निकाल दिया. सोर्स निकालने के बाद नेटवर्क में क्या एनर्जी विल बी प्रेजेंट बिकॉज ऑफ इंडक्टर एंड कैपेसिटर. बिकॉज इंडक्टर कैपेसिटर उस समय तक कुछ एनर्जी स्टोर करते ना, that energy will be present in the network, but resistor will never store any energy, it will never save any energy. So इस केस में क्या होता है सर, the energy present in the inductor will be taken by, or capacitor will be taken by the resistor. So here in all source free networks, energy present in inductor capacitor will be taken by a resistor, and at steady state network will be purely, sorry, but energy they cannot give up to infinite amount of time na, so the total energy will become zero over a period of time. ठीक है. So here in the source free RL circuit, that is like this. It is having some initial current I naught, okay, and some resistance, okay. There is some voltage V, and okay, listen. Now please see here. I am not going for the derivation. What is the current IL of T for T greater than equal to 0 is given by the formula I naught e power minus T by tau. Direct formula there only, where tau is equal to L by or L equivalent by R equivalent. ठीक है? What is VL of T? L DAL by dt. That is equal to minus, because minus will come, L I naught by tau, but I naught, tau is L by R, so minus R equivalent into I naught e power minus T by tau. The energy in the inductor will come negative, voltage in the inductor becomes negative, current positive, because we assume it is current is energy is absorbing, but it is originally delivering the energy. So the polarity, voltage polarities will reverse during this period. So this is about this. And energy in the energy formula EL of T equal to half L I square. That is half L I naught square e power minus T by tau by 2. Tau by 2 is the energy time constant. Because if you square it, you get 2T. Na? So this is our RL circuit analysis, guys. The same way we can do for RC also. For RC circuit also, V naught and C are the initial voltages of the capacitor, and you have a resistor. I assume always current is from positive to negative, but sometimes it may be negative to positive, discharging भी हो सकते, but assumption तो हमेशा ऐसा होना चाहिए. So here VC of the formula after derivation will be V naught e power minus T by tau, where tau equal to RC. IC of T equal to C dV by dt minus V naught by R equivalent e power minus T. Energy in the capacitor, tau of energy. Tau of energy is generally less than tau. So this is for RC. For RLC, we go by Laplace. We discuss that later, because it is a second order system. Next, the next model 2 is, okay, network with source. Means after switching action, network contains a source, but only initial or final values. Here, replace network by equivalent, that is open circuit, short circuit, etc. Here one important point. What is DAL by dt at time t equal to 0 plus? This is our most asked question. It is given by the formula VL of 0 plus by L. Because what is VL L dA by dt? So DAL by dt is VL by L. Similarly, what is dVC by dt? T equal to 0 plus. It is VC by IC by C. Because IC equal to C dVC by dt. Similarly, what is d square IL by dt square? These are the most asked questions. I mean, so that will be d by dt of dAL by dt. 1 by L dVL by dt. This will be 1 by C dx by dt. These are the formulas which are we are going to use these formulas. Okay, that's why this is the second model they can ask. But they ask response only at 0 plus and infinity. Last model, network with sources. Okay, response for time t greater than equal to 0 to infinity. Here, for RL circuit or RC circuit, formula will be total response is equal to final value plus initial value minus final value into e power minus 3 by 2. This is a formula, standard formula you can remember, or go by Laplace transform, it is your convenience. So for example, RL you take. What is IL of t? VL also you can use the same formula, but VL can be easily obtained with the help of L di by dt. So IL of infinity plus IL of 0 minus IL of infinity e power minus 3 by 2. Tau is L by R. Similarly, if you take RC circuit, what is VC of t formula? इसमें आप exceptions तो substitute कर सकते हैं. That is, when this is zero, what happens and all. And there is another called model 4, special case. That is when you give pulse as the input, multiple switches are present in the network. This we discuss tomorrow the theory. Okay, forget about it now because अभी तो ज़्यादा theory आज discuss तो किया. So we should go for the problems now. Ready for the problems? Almost 1 hour तो हम केवल theory discuss किया आज. ठीक है? चलो, let's start the problems. Okay, Aryan, ready? Okay, I hope it is visible. So let's start. Give a try, guys. So the transient free condition, okay, that is we discussed little later. Remaining filter, all the source free circuits, so the energy in the steady state, the DC excitation, the nature of the circuit, with the DC sources, the energy in the circuit, all these options. Okay, option C. Okay. So with DC sources, the energy present in the steady state. If source is present, it will reach maximum. For the DC excitation, the nature of the circuit in the steady state, it is resistive because inductor acts as short, capacitor acts as open. For all source-free circuits, energy present in the steady state will be minimum. I explain all the conditions. Transient free condition will happen in the AC input only. So that is we will discuss little later. Okay, P is 1, P तो 1 है, Q तो 4 है. Okay, P1, Q4, R R5, S3. Next question. So give a try. Last 5 seconds. Hang on. Chalo. So the DC transient steady state response depends on steady state. DC may suppose you say steady state response. Suppose if it is a RC circuit. Okay, steady state may this will be like this now. Okay, or you take current source. Steady state may it will be like this. Okay. Suppose here you have something R1, R2. Okay, whatever may be, steady state response depends on its voltage, excitation, and resistance values, but not on the capacitor inductor values. So excitation of the magnitude correct, circuit constant correct. The initial energy is present. मैं already बताया. Final value will never depend on the initial value. So only P and Q. ठीक है, सर्क्यूट कांस्टेंट में डिपेंड होता है भाई, सोर्स का वैल्यू के हिसाब से आपको यही पे जो मिलते हैं ना, वी आर टू बाई आर वन प्लस आर टू. एलसी का वैल्यू में डिपेंड नहीं होता है, बट इट डिपेंड्स ऑन द अदर सर्क्यूट कांस्टेंट्स, राइट. सो लेट्स मूव फॉर द नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन सिमिलर मॉडल. एक और क्वेश्चन है भाई, ट्राई कर लो. आज ज्यादा क्वेश्चंस नहीं कर रहा हूँ, बट जितना भी टाइम है तो उतना टाइम पे जितना भी पॉसिबल उतना आई विल डू इट, बट वी विल डू मोर. आई मीन थ्योरी तो हो गया ना, कल क्लास में पूरा प्रॉब्लम्स ही करेगा. ऑप्शन डी बोला है आर्यन. ठीक है, चलो लेट्स डू इट. सो इन द डीसी ट्रांजिएंट स्टेडी स्टेट वैल्यूज डिपेंड्स ऑन द इंडक्टर वैल्यूज. गलत है. With DC transients, L and C will elements will store their energy during the steady state period. Perfect. In all the source free circuits, energy in the steady state is generally, most of the cases, it is zero. Right? So Q and R. All the questions are from the theory we have discussed up to now. Similarly, just it's a quick revision for your theory. Try this. Steady state current through the capacitor is maximum. Steady state energy in the circuit is minimum. Final values are independent of magnitude of the sources. Final values are function of the element values. In steady state, the nature of circuit is resistive. Okay. here. Steady state, the current through capacitor is maximum. Capacitor acts as an open circuit. In steady state, the energy stored in the network is minimum. Actually, it is possible for source free. The final values are independent of magnitude of sources. नहीं, source के value पे depend होता है. Final value of function of element values, correct. But not inductor capacitor. Resistor का value में depend होता है. ठीक है. Steady state, the nature of the circuit is resistive. ठीक. Okay. So S and T तो सही है, पर पहले T तो सही है. Okay, T is 100%. Steady state nature of the circuit is resistive. So T सही है तो ये दोनों निकल सकते हैं. According to examiner, it is not minimum ना, it can be maximum also if source is present. So आप ये remove कर सकते हैं. So SK तो ले लो यार. Option D आप क्या दिया? Right, option D आ गया. Next question. Okay. You can comment the answer. 0,0 is the answer. In inductance and capacitor connected in series. Okay. Unit step voltage is applied across the combination. Then initial and final values. Unit step means this one. Okay. So at time t equal to 0 plus, inductor acts as a open, capacitor acts as a short. Infinity, inductor short, capacitor open. Both the cases, current कितना 0 ही होता है. ठीक है. But actually, how you should do this analysis is for this particular circuit, original way of doing the analysis is like this. Take the input as 1 by S. This is SI and 1 by SC. And take this as the current I of S and do the analysis. I of S equal to 1 by S by SL plus 1 by SC. This is the proper way because the second order system. So SC into 1 by S by S square LC plus 1. C by S square plus 1 by LC take into 1 by LC. So 1 by L into S square plus 1 by LC. You can say 1 by root LC whole square. You multiply with root LC. Okay. So this is what you will be getting it. I of S equal to 1 by L. Okay. Root C by L. 1 by root LC by S square plus 1 by root LC. What is the inverse Laplace transform, sir? Root C by L. Okay. Root C by L into sin omega n. ठीक है. So sin 0 तो 0 होता है ना. There is no I mean, here, this is the response you will be getting it up to infinite amount of. Actually, strictly speaking, there is no steady state here. Next question. Try this. Thoda sa, it's not. Give it a try. Option C is the right answer. Let me explain. Here he asked steady state response. Impulse response कितना k e power minus 2t. H of t equal to k e power minus 2t. Okay. V naught and vi equal to sine 2t. Right. H of s equal to v naught by vi. So what is v naught of s? H of s into vi of s. So here k by s plus 2 into what is the Laplace transform of sine 2t? Sine 2t is 2 by s square plus 2 square. Right, this is 2k into 1 by s plus 2 into 1 by s square plus 2 square. इसको partial fractions तो apply करना चाहिए. So it will give you 2k by 8 into 2 by s square plus 4. अब partial fractions करके check कर. ठीक है. So 2k by 8 into s square a by this one will give you cos 2t minus sin 2t plus e power minus 2t. At steady state e power minus 2t will become 0. Then what is your v naught of t? 2k by 8 into you multiply with 1 by root 2. Okay. This is at steady state and speed. This can be written as cos 45 cos 2t. एग्जामिनर को ऑप्शन साइन पे दिया cos पे दिया साइन पे दिया ना. So you take sin 45 minus cos 45 sin. This will be a by 2 root 2 sin A cos B minus cos A sin B. What is the formula? Or cos A sin B, ये तो साइन है ना, बिकॉज इसका इनवर्स तो साइन है, साइन 2t माइनस cos 2t. So here root 2 common ले लो. So here cos 45 sin 2t minus sin 45 cos 2t, because 1 by root 2 can be written as 45 degrees. So sin A cos B minus cos A sin B, sin A plus B, sin 2t plus 45 degrees. So k by 2 root 2, 45 degrees can be written as 5 by 4. Okay. Option C. Okay. Next question. Multiplying the magnitudes, adding the phases. कर सकते हैं यार, because transfer function तो दिया. Okay. Omega equal to 2. So here, yeah, let me check that. H of s equal to k by s plus 2, no? K by j omega plus 2. Substitute omega equal to 2. What is h of j omega? K by j2 plus 2. ठीक है? So k by 2 root 2 angle minus 45. ऐसा भी कर सकते हैं. Happily. What is V naught of t? K by 2 root 2 into sin 2t minus 45 degrees. बस हो गया. This is a simple method. Okay. Multiplying the magnitudes at the phases. Perfect. नहीं तो इतना करना. So next question is ready for you. So give a try. Next question. So let a first order low pass RC circuit is excited with a unit step function. The voltage response across the capacitor is. First order RC low pass filter. This is the low pass filter. Okay. It is excited with unit step means 1. The voltage across the response across the capacitor. So what is VC of infinity here? 1. VC of 0, 0. Tau RC. Direct formula. What is your VC of t? Final value plus initial minus final e power minus t by tau. That is 1 into 1 minus e power minus t by RC. Perfect. Right? Chalo, next question. Similar model, another question. Last 10 seconds. A RC circuit initially at rest has a step voltage signal. The voltage response V of t is this. If there is no, see here, initially relaxed. इसका मतलब VC of 0 is 0. In that case, he got the VC of t equation as 1 minus e power minus 3t. So, firstly, what is VC of t formula? When VC of 0 is 0 in this case, then 1 minus e power minus, so VC of infinity into 1 minus e power minus t by 2. This is the formula. Okay. The previous formula पे मैं VC of 0 को जीरो substitute किया तो ये मिलेगा आपको. So that is given by 1 into 1 minus e power minus 3t. ठीक है. इससे हमको क्या पता? VC of infinity कितना आ रहा है? 1. Tau कितना? 1 by 3. ठीक है सर. Now इस वाला सर्क्यूट को इनिशियल वोल्टेज कितना ऐड किया? VC of 0 equal to 3. Then now the new VC of t is final value plus initial value minus final value e power minus 3t. That is 1 plus 2 e power minus 3t. So option C is the right answer. No, not D, option C. Okay, final plus initial minus final. Here initial is 3. Initial more than final है तो plus आए. Next question of similar model. ठीक है, कोई दिक्कत नहीं. मिस्टेक्स तो कर लो यार, जितना भी पॉसिबल है तो उतना मिस्टेक्स कर लो. एग्जाम पे नहीं करना. Right. For the RC circuit, for an RC circuit, the response for the unit step excitation is 1 minus e power minus t. So when, see here, when input is 1, Vc of t is 1 minus e power minus t. Okay. Here what is Vc of infinity? 1. Fine, it is clear. And tau is equal to 1. Right. Now if response for the excitation of same circuit but input is 2. Now what is Vc of t? What is Vc of infinity here? 2 now. At steady state capacitor acts as an open circuit and the 2 will be present here. Yes or no? So what is Vc of t? 1 minus e power minus t by tau input. It's a बहुत आसान क्वेश्चन है, ठीक है, बिकॉज स्टडी स्टेट में ये तो प्रूव बस, ठीक है. चलो नेक्स्ट. Okay, let's do this question and end the class for today. You don't take that. Very good. ठीक है. Anyway, corrected means this is the right answer. Option C. चलो. Here when input is 20t, na, go by Laplace. The Laplace, this will be 20 by s square. This is 1, this is s1. So what is the current I of s? Because the second order input go by Laplace always. What is your I of s? All second order systems we try by Laplace because it makes analysis easy. S square into s plus 1. So this will be generally partial fractions ऐसा होता है ना, a by s square plus b by s plus c by s plus 1. That will give me 20 by s square minus 20 by s plus 20 by s plus 1. ठीक है. Then inverse Laplace transform आपने अप्लाई किया तो 20t minus 20 u of t plus 20 e power minus t u of t. So here I of t equal to 20t minus 20 plus 20 e power minus t for t greater than equal to 0. 20 into t minus 1 plus e power minus t. So minus 1 plus t e power minus t. So that is about your today's class. Yeah, पार्शियल में टाइम लगेगा. चलो, because I know the answer मैं directly लगा. So बाकी क्वेश्चंस जो होता है ना वो कल क्लास में हम डिस्कस कर सकते हैं. We have good number of questions. So this is the batch going on for plus subscribers, guys. If you want to go for what we call the mission IRMS CSC mains batch, okay, this is our electrical team for this mains batch, that is IRMS and civil service batch. This batch is also started. So it contains both the GATE educators and the civil services educators. आप इसमें subscription लेना चाहे तो you can use my code Shankar10 and join that. Okay, so UPSC combo पे आप ले सकते हैं. So use the code Shankar. ठीक है. So गेट का एग्जाम लाइक आपको एक्सपीरियंस चाहिए तो अभी आप इस वीडियो का लिंक वीडियो के डिस्क्रिप्शन पे लिंक अवेलेबल है, इस पे कंपलसरी सब्सक्राइब करो। आई मीन इट इज कम्प्लीटली फ्री फॉर यू, जस्ट एनरोल फॉर इट। जनवरी में 4 एग्जाम है आपका गेट एग्जाम के पहले, ये तो बहुत 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 इंपॉर्टेंट है भाई। क्यों इंपॉर्टेंट है सर? क्योंकि थ्रू दिस, okay, you will be getting the competition, you will be knowing about the real competition throughout the India is going to participate in this exam, and live pay you will be knowing your mistakes. And before writing the original exam, if you write these many examinations, definitely it will give you an experience to avoid the silly mistakes, and absolutely free पे आपको मिल रहा है। and if you get a good rank you can get the scholarship also। इसमें enroll करने के लिए it is completely free यार, use my code shankar 10, ठीक है? so thank you very much। सो अनअकैडमी पे कोई भी सब्सक्रिप्शन लेना चाहिए तो यू कैन यूज, और योर फ्रेंड एनीबडी वांट टू टेक द सब्सक्रिप्शन, यू कैन यूज द कोड शंकर। थैंक यू। सो दैट्स ऑल फॉर टुडे। टुमारो पूरा प्रॉब्लम्स ही करेगा, ठीक है? कल भी सेम टाइम पे मिलेगा। इसके बाद 2 क्लास में एसी एनालिसिस करके मैं खत्म करता हूँ दिस टोटल क्रैश कोर्स। थैंक यू वेरी मच, सी यू। नोट्स टेलीग्राम पे देने के लिए ट्राई करता हूँ, ठीक है? इट्स आई विल ट्राई।